You say roll.
Roll.
Roll the recording.
Okay. So thank you guys for introducing yourselves briefly, and that helps me out to know where everyone is at. And dates and times are really tricky in R, and there are workarounds for it, but there's also kind of native classes of data objects in R that are intended to handle exactly dates and times, including time zones, which is another pretty confusing subsection. So we're going to go over all of that today. I'm going to start with how to read in dates and times from different formats. And we're going to do that just kind of like in base R. That's actually when I started learning all of this. Base R did the trick. It was before lubridate became really popular. And I still think I still reach for base R regularly for that reason. If it ain't broke, don't fix it. It still works. There are a couple of cases where I do find the functionality of the lubridate package to be better or more intuitive. And so we will go to that towards the end. But we're starting. You don't need to have anything besides just regular RStudio pulled up if you wish to follow along. I did send out an email right before, and you can navigate to that GitHub folder or the actual notes page. I will be following that content. We'll see how well I can stick to the schedule. Probably not well at all. Yeah, so one of the reasons that I'm going to continually emphasize a theme throughout this will be unambiguous, by which I mean the date time format should be unambiguous, and then the time zone should be unambiguous, because those are where I feel like errors can really creep in, and what causes, people to want to just throw it all away and just start using their own kind of system of like day of year or hour of day to try to get around some of those issues. So I'm going to oh my goodness. I'm going to share my screen here. This is just the notes page, so you have it yourself. You guys can see my screen here? Yes? Okay, great. So in base R, we're going to start with dates first. Dates being the easier without times, right? So this is month, day, month, year, month, day, year, whatever the format it is. The date object is a native R object, and it's stored as the number of days since a reference date. And in this case, the reference date is January 1st, 1970. And so you can actually get the number of days out of that. If you have a date object, you can use as.numeric on it, and it'll show up as a date, and you can use as.numeric on it to extract the number of days since January 1st, 1970. It accepts, in order to use this base as.date function, it accepts character strings or other time objects, these POSIX objects, which I'll be talking about very shortly. There is a default. I do want everyone to be aware that there are default date formats. There is a correct way, basically, to write numeric dates. It's based on this ISO 8601 international standard. I basically looked it up on Wikipedia to learn a little bit more. But you're right, there's different conventions locally, right? In the United States, we do month, day, year. A lot of times internationally, it might be some other way in different parts of the world. And so this is kind of like the standard way to be unambiguous. There's that word again, about which parts of your character string are well, the year is usually less ambiguous, but like sometimes it can be ambiguous whether it's the day or the month that the character string is referring to. So this is borrowed from XKCD. Probably recognize the font. Oh no, I'm getting messages. Why am I getting messages? Waiting room, can somebody David, could you let Heidi in from the waiting room, please?
Yes, I will try. Participant.
Here. Sorry, there we go. Yay.
Sorry, I didn't get the message.
Huh, maybe that was just me then. So sorry. Hi, Heidi. Sorry about that.
No, I'm sorry. Sorry I was late.
No worries. Close that. Okay. So ideally then, the data that you have, the date is in this standard unambiguous format. But from my experience, that is oftentimes not the case. One of the reasons it's not the case a lot is actually Excel does weird conversion things, right? Like if you open something Excel tries to guess at your date time format and then does something to it. So that when you read it, if you save it, even if you save it back to CSV and you read it into R, it imposes its Excel-ness on it and makes life a little more complicated. So there are arguments in this as.date function that include, we're going to switch over here now. Wait, hold on. There are arguments in this as.date function. And if you would like to follow along with me here, that'd be great. For the format. So we can just do a test case of as.date. For some reason, the D is capitalized for as.date. I'm not sure as to the history of that. So the character string is something inside quotes, right? And if we gave it an unambiguous date format, so today is 2022-04-27, and then if I enter that, goes to the console, it reads just fine. It doesn't have any errors. If I assign this to X, I can check the class of X, and it's of class date. So this is like a class of object inside R. It is a date. If we did as.new, I'm just down here in the console now, as.numeric on X, apparently today it has been 19,109 days since the 1st of January, 1970. But that's if it's an unambiguous format, right? If it is a more ambiguous format, then we have to do something about that. And so here in the notes, sorry, switching screens back and forth here. In the notes here, you can see I've kind of typed out a simplified version of all of the different codes for indicating what format your date actually came in. And I don't always remember this. Some of these are hard, like the fact that abbreviated month is lowercase b and full name month is capital B. Can be a little hard to remember. So I type $strip time into my console and I scroll down, and the help menu of RStudio here, instead of gesticulating, I will show you. If I do $strptim, you don't have to know, we're not using this function. This is actually used within one of the functions we're going to use later. But if we go down here, scroll, it's a pretty long help. But there is a exhaustive list of all the abbreviation codes for different ways that dates and times might be represented in a character string. But in the notes, I provided the most common ones, at least for dates right here. Okay, so if we had a more ambiguous, if we were trying to say, let's do as.date, if we were to do April 4th, or it's not April 4th, it's April 27th, 2022, and we tried to run that, we would get an error because it's not in a standard unambiguous format. And we would need to add a format argument. And this format argument also needs to be in quotes. And it uses that % symbol right over here on the right. I can see, okay, so I have April written out, and I happen to know that that's a full month name, so it's capital B. So I need a % capital B. And then outside of that, it needs to look exactly like what's inside your character string over here. So that's the % capital B takes care of the April. Then comes a space. So in my format, that takes 27. Then I have a comma and a space. And I need to reproduce that exactly and a space. And then I had the 4-digit year. I happen to know that's capital Y. So let's just, yeah. So there's lowercase y, year without the century, and then capital Y is year with the century. So we've got the 4-digit one. We're going to do % capital Y. If I do that, oh, it doesn't like that. Why doesn't it like that? Let's see. Oh, it's not M, it's D. I'm silly. This is not the month, this is the day. So there we go. And I bet that if I, if I had, and in addition to that error, if I had done something like forgotten the comma, I think it wouldn't have read it either. So really the format, this is one of the things that can be frustrating, is that format, getting this format exactly right. It has to exactly match what's in your character string that you're inputting in the first argument. So all of the date time representations have to be represented by these % whatever letter symbol, and then all of the spaces or commas or dashes or slashes or whatever have to also be perfectly matched inside this format argument. Okay, so I can put that all into a Y object. And yeah, so now we have, they're the same thing. You'll notice those, I guess I can ask, yeah, so you can see here, they're both. And one thing that's interesting about date objects is that even though they're dates, they actually do have a time zone. If you notice here in the right-hand side in the environment where my mouse is, the default when you don't give it a time zone is UTC, or Coordinated Universal Time. Same thing, it's the successor name to GMT, Greenwich Mean Time. So that's the default. And I will I will show an example later of why why it can be important to have a time zone argument inside of a date, even though you might not think that dates have time zones right off the bat. Okay, next I'd like you guys to try, I'm gonna put these here in my screen, and I will also drop these into the chat. If you could pick, I guess, yeah, pick yourselves one of these, and hint this last one, this 156 refers to the day of the year, so it's the 156th day of the year. Try to convert these into this date object in R from this character string, and I'll give everybody, I'll set a timer for 2 minutes to do so. Sorry about that. Thanks for reminding me. I was messaging people in the waiting room, and I don't think there are any people in the waiting room. Okay, that's the 2 minutes. Would anybody like to share? Or you can feel free to share your screen of what you did, or just speak up, unmute yourselves and tell us how it went. Dan, if I may pick on you, what happened when you tried this?
Yeah, I'm not the best one to start out on.
Okay.
I had some
That's okay.
trouble.
You can tell us what you tried.
Well, I tried something on the our program wasn't working on my other laptop. So now I'm trying it on another one. So
Okay, I'll have to
I-
pick a different victim, I guess.
yeah, I'll try it on the next one.
Thanks, Dan. Christina?
Yeah, I was able to get through all of them. And the one
Nice.
that I had never seen before or used the sort of $ or % and then letter was for the last one with the day of year, which is apparently a J, lowercase j.
Yeah, that one's a new one to me too. So that's again in the you can find it in your strip time help file, or it's on the notes page as well. Great job getting through all 4. All right, I'm going to move on to dates and times, just because I think I'm already behind schedule. But so dates and. So that was dates, right? And we're going to come back to dates and as.date in a little bit, as I said, when we talk about time zones. But the next most common thing you might see from maybe automated sensor data or something that you take frequently is a timestamp, right? So it's got a date and it's got the time next to it. Just like dates, there is a standard, the ISO 8601 unambiguous standard of what it should be, and that's 4-digit year dash 2-digit month dash 2-digit day space hours colon or 2-digit hours colon 2-digit minutes colon 2-digit seconds. You also don't need the seconds technically in there. It just assumes 0. And I personally have not had to dealt with any data where the seconds mattered. But let's see here. I'll share my screen again. This name, you probably have, if you've done your own Googling, you probably have seen this acronym or name POSIX, and you might be like, what is that? I've been using it and saying it for years without knowing what it stood for, but this time I looked it up. It stands for Portable Operating System Interface, primarily for Unix. Yes, that's where the X comes from. And it is my understanding that this is a really, like, this is not an R thing, right? This POSIX is across lots of different computer languages standard for how dates and times are represented. And there's 2 flavors of it. I'm only going to briefly cover the first flavor because we're not going to work with it. And in my work, I rarely see it used. It's this POSIX LT, and I think it stands for local time. And it's the L, it's like local, but it's also a list. So it's got a list of elements for second, minute, hour, day, month, year. And it's a little bit more unwieldy to work with for the computer because of that. So that's all I'm going to say about POSIX LT. POSIX CT is what I'm going to be, when I say POSIX in the future, I'm going to be talking mostly about POSIX CT. And it stores, akin to the date format, it stores date time as the number of seconds since January 1st, 1970. So it's another thing where if you did as.numeric on it, there's a number underneath there, and that's what allows you to do kind of comparisons and computations with it. So you can subtract 2 dates and times, for example, to get the difference. Because underneath the hood is actually a number of seconds, and you can subtract those number of seconds and convert it to whatever date unit you want. And so this POSIX CT is the standard choice for dates and times in R. It can also be used to store dates without any times in it, and it can be, and you can store date times without any seconds in it. But today we're just going to work with the kind of the whole shebang, the standard, which is this 4-digit year, 2-digit month, 2-digit day, and then hours, minutes, seconds, separated by colons. So that's the ISO 8601 standard. Again, if we go to R, if we did X, and I'm going to pick a different. So this is as dot EOSIX and then CT. It pops up also. If I were to do that standard, I can pick a different day, maybe this day in 2021. So it's about 11 o'clock. It's about 11:30 now. there's no errors. And it just, I can, if I typed X down here, it would give me, oh, exactly that. And if I did class X, it tells me it's a POSIX object, basically, either POSIX CT or POSIX LT. And if you did STR on it, I'm not sure why both of those show up actually. But if you do STR on that X, then it more clearly tells you that you have a POSIX CT object on your hands. When I type this into the console, it actually, it shows up here that I have MST, Mountain Standard Time, which is a default of POSIX, right? So I didn't, just like before when we had UTC for the date, we didn't say anything about the time zone, so it assumed UTC. When we're dealing with POSIX, it doesn't assume UTC, it assumes your local computer time. And you can check your local computer time, again, typing in the console here. Is this big enough? I'll make it bigger. Okay, make it slightly bigger. Sys, so capital SYS dot TIME with nothing in the argument, just a blank. That gives me my local computer time. And my computer is set to Arizona time, where it's Mountain Standard Time year round. So that's why when I type this in here without a time zone, it assumed that. I don't like these assumptions can be dangerous, right? It might work all well for you now. It can also be the case that you want your data to be reproducible, you put your code online when you publish a paper, someone else goes and tries to reproduce your analysis, but they're in a different time zone. Their computer is in a different time zone, or one of your collaborators' computers is in a different time zone, or they're in the part of Arizona, for example, on the reservations, where they don't use, where they don't follow Arizona's non-use of daylight savings. And so you could be off. I mean, you might only be off by a couple of hours, but that might really matter for your analysis. So to avoid ambiguity, it's always a great idea. Just going to repeat that several times, to include the time zone when you're reading in, you're converting from character string to one of these date or date time objects in R. Okay, what happens if we have a ambiguous time format? You would still use as.POSIX CT, but for example, what if we had, oh, let's do APR for 2021, and we had, let's say, 6:30 in the morning, like that. If I did that, I would not be able, that would not work right away. Like POSIX, the function can't guess at which elements in here are date, or or is the hours, the minutes, the month, the year, all those elements it can't guess. So we need to add that format argument again. And just like before, it's still all these strip time percent and then a letter. And then we have to mimic the spaces, the commas, what have you, exactly. So in this case, we have, let's see, this is an abbreviation of months. So I believe it's percent lowercase d. And then we've got percent day, comma, percent capital Y, comma, percent hours, colon, percent M minutes. Wait, is that right? Let's see. Capital M is minutes. Ah, I thought so. Lowercase m is month, capital M is minutes, and I think that means capital H. Yes, capital H is hours. So that's another kind of confusing thing. You might be on the right track thinking M is minutes, but M minutes is actually capital M. So again, that's why I have to refer. I do the dollar question mark strip time a lot and refer back to this. Oh, I got it in the first try that time. That actually worked. Hooray. And so if you're reading in a data sheet and somebody else did an Excel and it's got some weird date time format and you need to convert it to an R POSIX date time format, you can use the format argument. I have a question in the chat. Ooh. Oh no, Christina, thank you for sharing your answers there. Okay. So, and we saw the example of it defaulting to our sys.time time zone. The last way, this is not, I don't do this very often, but the last way that you might receive information about dates and times and need to convert is not in a character string, right? So this is assuming that you have a spreadsheet somewhere and the whole column is all in this format and you're converting the whole column, for example. And it's just all one character string. It's a mix of numbers and letters. You could also have a spreadsheet. There may be some instruments that put this where you have a column for the year, a column for the month, a column for the day, a column for the hours, the minutes, and the separate columns for the hours, minutes, and seconds. And those are all actually numbers in there. They're numeric in there and they're read into R as numbers. In that case, if you want to combine those elements together into a date time, you use the ISO date or ISO date time functions. And so an example of that was, I think it's ISO. Yeah, so there's the two, these are both base R. There's ISO date and ISO date time. And their arguments are fairly straightforward. Year, month, day, hour, minute, seconds, and then a time zone argument. And in the date, you notice that the hour, the minutes, and the seconds are set to 0. Or sorry, the hour is set to midday, the middle of the day, 12, and then the minutes and seconds are set to 0. So you would only put in year, month, day. Year, and here we don't need quotes here, right? Because this is, again, we're assuming numbers here. So let's put just some, coming up with a random date here, month, 12, date, or day, 5. Let's see what happens if we do that. No arguments, no error messages. If I type Z down here, okay, gives me December 5th, 1999, middle of the day, because this is a date itself. We're assuming the time information is not relevant here, so it's just setting it to the middle of the day. And the default here, which we saw a little bit when the, look at here too. ISO date. Default is GMT. And again, GMT is the same thing as UTC. But why sometimes it's GMT and sometimes it shows up as UTC, that I'm not so sure about. Perhaps some kind of legacy. So the ISO date time is a little bit different. We notice that this one, the time zone is blank. When it's blank like this, it means that it is inheriting from your local time. So your sys.time time zone, it's inheriting that time zone. So again, the defaults here are different. Oh, yeah, I need to pause my messages when I'm teaching. Okay, so I think we have covered, where am I? We have covered, so here in the notes again, I've reproduced the most common elements you might need to know for the formats. And I've covered how to get to a POSIX object when you have a character string and also when you have the different individual elements as numeric. So why don't we guys try converting one or all of the following. I will drop this into the chat here. Christina says UTC is a time standard and GMT is an actual time zone, but the value of the two are equivalent, I believe. Okay, so with those ones that I dropped into the chat, you can pick one or several to go ahead and try converting into POSIX. That last one there is as if it was numeric, and the first 3 are if they were character strings. So set my timer again, check back in with you in about 2 minutes. Okay, that's roughly 2 minutes. Would anybody else like to share what they did to convert these into POSIX? I might call on Leah this time.
Yeah, like a very slow, and I'm just doing the first one because I have to keep looking back at the.
Oh no, I expected
okay.
people to do one, really. Christina just, you know, above and beyond.
Okay. Sorry. Almost done. No. Oh, what if it did not work? So maybe you shouldn't call on me.
Sorry,
I said what I did, it did not work. So maybe
would you
shouldn't-
like to share your screen and we can all take, we probably can learn more from errors than we can from getting it right the first time.
Okay. Sorry.
I mean, if anything, this should be a lesson in an exercise in never have dates in these awful time formats, date time formats ever.
Wait.
And
this
train.
is,
Huh.
hour,
Hours,
minute, the
days.
month. Oh, I forgot the day.
Yeah, I think you're really close.
Oh, okay. Forgot the day.
Yeah, let's try that.
Okay, there we go.
Woo! It worked. Great. Thank you for sharing, Leah. So close. Did anyone try the last one?
I actually have a question.
Oh yeah.
So the second one has seconds in it.
Mhm.
And when I looked at the possible options for seconds, there's a capital S and a lowercase s. It looks like for that one, it's a capital S. The definition for lowercase s is the number of seconds since the epoch. I don't know how to say that word, epoch. I'm sorry if you don't know the answer to this.
I
Off the
don't
top
know
of your
the
head.
answer for this.
I don't really know what it means. But when I did lowercase s, it gave me, I mean, it's counting the number of seconds and something, I guess. I don't really know. But that threw me off.
Did I put lowercase s in the thing?
Oh, you might, no, sorry. I was looking at the help page.
Oh, the strip time.
Yeah, sorry.
Okay.
Not at what you
No,
had.
no, I actually, I can't find the lowercase s in there either. Interesting. When I was looking at the strip time help file, I only saw capital S, a % capital S personally. Or here, I will show.
So yeah, and it says it's under a later section, actually.
Oh. There's like another
Yeah,
section of
when I
these?
searched for it, it showed up. There's like a little section at the end. It says the not in the standards unless widely implemented. So it's some unusual thing. So it's probably weird. Yeah, weird edge case or like
Tried to.
some historical thing.
Oh yeah, I can find in here, right? Like.
Yeah. I think the search is probably case insensitive. So
Here we
it's
go.
that one right there.
Output only.
Yeah, so I don't really know what that means. Probably take some Googling.
I don't know what an epoch means in this case too. There's like also like geological time. Epoch is a thing, right?
Yeah.
Okay. Yeah.
very
Interesting. I guess I always remember the hours, minutes, and seconds. All three of those have to be are capital. So it's capital H, capital M, capital S for hours, minutes, seconds. And that's the only way I can remember which one's capital or what capital M means versus lowercase m means. Like I only get it right like, I don't know, 70% of the time. Okay. There was something from before, which I neglected to go over, which is the date one. When I put this date format, this is actually directly from Excel. I was like looking at some of the Excel times, like formats. For one reason or another, you can select the date format to be this format. And I think it's so bad. Can you tell which one's the year and which one's the day? No, you have to guess. It's not unambiguous. Oh my goodness. Like this is the hill I will die on about make it unambiguous. And so with that, The next part we're going to talk about, thank you for sharing, Leah, and thank you for pointing out various intricacies of this. There is a lot of complexity there. Is time zones. And this is something I think that trips, I can't claim to be an expert on it. I went to Wikipedia. So both at the two functions we've learned, the two main functions we've learned so far, as.date and as.posixct, have an optional TZ or time zone argument. It's optional and they assume different defaults. As.date assumes that GMT/UTC is the default, and then as.posix defaults to whatever your computer's time zone is. There is a database that compiles all of this information, and it's like the TZ database. It's got some other names. It's also sometimes referred to as the Olson database, which you might have seen in some of the, if you've ever Googled this stuff, you've probably seen some of the help things that have come up. And so one thing you can actually look at in R is Olson names as a function. So Olson, capital O Olson, capital N names, all one word, and that's a function. And that will list you all 593 time zones for all, I mean, I think this covers, this is the international standard. So it covers everywhere in the world you could possibly be collecting data, right? And so, this is the Wikipedia page for it. I learned some stuff reading through this. These Olson names have a specific format. It's like an area / location. So the time zone we are in is America/Phoenix. And this differs from just the time, this is like an Olson name of a time zone because it accounts for, it accounts for the offset from UTC, the Coordinated Universal Times, and it accounts for when daylight savings is observed in different time zones and when that happens. So America/Phoenix, it always stays in Mountain Standard Time year round. But if it were the other, mountain time zone, America/Denver, that would be MST in the winter, MDT in the summer, with the whole spring forward, fall back, all that jazz already accounted for in there. So I feel like once, this is another layer in, but once you understand this a little bit and you know kind of like where you live and then the offsets from where your data might be collected, it handles a lot of that time zone change under the hood for you. And so you don't have to think too hard about it. The format, again, there's an area, typically a continent or ocean, and then the location is like a populous city or a small island. That's why America Tucson is not an Olson name, but America Phoenix is an Olson name. And the reason that this is important, even for dates, is that it affects whether, it affects how you switch between the two. So I need to get my other RStudio screen up here. And this next section on time zones. Let's do an example. Okay, we've already used X and Y a whole bunch, but and I know this is bad practice for if I were actually coding, but I can't be bothered to come up with better names for these. So let's do this time zone thing. Let's do the section as time zone conversions. Conversion between date, time, and date. So in this section, we have an X time, and it's a date time, sorry. So it's POSIX-CT. And I mean, I'm going to put it in an unambiguous format. Let's say it's 12:30. And again, seconds aren't necessary. And we do in this case, so we don't, because it's standard format, we don't have to specify the format argument, but we do wish in this case to be unambiguous and say that this is America, Phoenix. Great. If we did remember, as.date takes character strings and it also takes POSIX objects, right? So you might take your POSIX, your X, which is a POSIX object, and put it inside as.date, and it returns, oh, look you there, it returns the correct date. It's 2012, February 23rd. But let's do this again. Let's do another time that's slightly off. So it's still 2012, 02, 23, but now it's 8:30 at night. So. And then, oh my gosh, I turned off, closed my Slack and it's still popping up. My goodness. Still America Phoenix. And I did as.date for Y. It's actually going to tell me that it's the 24th. It's February 24th. So this is the case in which it is important to have the time zone argument. So it's also called TZ inside. So if you have a time zone for your date, date time, and you want to preserve that in your date, you have to add that America Phoenix here as well. And that will get you the correct, oh, it's February 23rd instead of being off. Are there any questions about this? I feel like this is, it took me a long time to wrap my head around.
So why did it go to the 24th? Was it using a different time zone?
Yes, it was using GMT or UTC. So
Okay.
by the time it's 8:30 at night in Phoenix, over in England, I guess, it is the 24th.
Okay.
So it kept the date, like, right, the date is correct, but the date, where in the world do you want that date to be basically referenced to? We want the date to be referenced still to the same time zone that our date time was in. And this is something I do often actually, because I might have a timestamp on a sheet, maybe some automated data that comes in half hourly or hourly. And then I want to do some summary statistics to the daily level. I want to know what the total precipitation was or the mean flux was for a day. So I want to extract the date component out of the date timestamp. So I would do this, and then if you neglect to do this time zone argument onto the as.date, you can be off. And for, I think here to UTC is like 7, I think we're a 7 hours difference. So you basically, the last 7 hours of the day would be considered the next day, and that would it would certainly mess up your daily calculations. Okay. There's no questions for that. The next thing I'm going to show is differences. So doing calculations, you can do all kinds of calculations. Now that you know that these date time objects are under the hood, the number of seconds since a reference time, in this case, January 1st, 1970, you can do calculations with them, right? And so in this case, you might do y minus x. And it tells you there's a difference of 8 hours between 12:30 and 20:30. Under the hood, though, even though we're just doing this with this minus sign, under the hood, the function that's actually running is diff time. You guys may have encountered this. So, oh, I guess it's y minus. I guess we need to do y comma x. I wasn't sure. So to get the same answer as y minus x, it's running diff time y comma x. And so maybe I'm going to assign this to D. If we look at the class of object that is, it's actually a class of itself. It's not just a number, right? It's diff time. Okay, so the numeric value is 8, and then the attributes is the units, and its units in this case is hours. Note that we never actually said here, like when we did y minus x, we didn't tell it to return the difference in hours. Maybe we want the difference in days. Maybe we want the difference in minutes. It gave us hours. It does, there is an algorithm in there. You can read the diff time manual, basically the help file, to see the logic about which unit it returns it in. But you might want to be in control of that. right? So a way to be in control of that, well, let me look up diff time and show you guys. You can have this units argument, and the default is auto, and there's an algorithm again for calculating what the auto is, but you can also tell it what to be. In this case, we want to do units equals days. Maybe we care more about the days. Then we type D. It's a third of a day, and it's going to give it to us like that. If you're making a new column for, say, in one of your spread in like a data frame, then you want to calculate the number of days that's different. You probably don't want this diff time data type to be that column, right? You might wrap instead, you might do something like as.numeric D, and that will give you just the number and not that attribute of additional attribute of the units. And then you would just have to know, or like keep in your column name the fact that this difference is in days or hours or minutes. So just wanted to bring that to your attention, because sometimes I try to do calculations and it does the auto and it tries to guess the unit that I want, and it's not the unit that I want. So diff time is your friend. Diff time sometimes wrapped inside a as.numeric. Okay. Well, I would like to stop for a second. That covers the first hour introduction of material. Some people had to leave. Some people only had an hour, and I know, Leah, you only have an hour. But are there any questions at this time? Philosophical questions, dates, times. Have we gotten to the part where you have questions yet, or have I only covered what you already know how to do? Gabby,
It's a really good refresher. You covered a lot of things that were new for me, specifically, Jessica, because I've only ever like taken a stab at dates and times. I don't usually work with temporal data. But one of the things that I am running into a problem with is trying to temporally decide when someone is taking a drug based on large database information, right? So I can decide when you got the disease, or when someone thinks you got a disease, and then when you took out your first prescription, potentially I could have something like that. But this like temporality about like when they started, when they stopped a drug. So like playing with dates within those ranges and being able to, interact with different dates together. I guess that doesn't really make sense, but like based on this date, how long have you been taking this drug kind of thing, or
okay.
kind of,
So it sounds like you would need to have things in a date, at least a date format, and then you might wish to do some calculations on those dates.
right. And also some like, just even filtering based on the dates, right? Or even pulling the right data. So just kind of lost there, but thank you.
Actually, I forgot, I didn't even think of that, but that is something now that, you could have it just in a character string, but you can't do very much with the character string. Once you convert it, you can use the filter in dplyr and filter all the dates since a particular date, for example, or like use a case when and do different assignments that way.
Right,
So,
that makes sense.
Yeah, you can, once it is in a date, do I have the ability to show this on the fly? Not quite yet. I'll after the next section, when we read in some dates, I can show some of what I mean by filtering. It is when you're filtering by something, the thing that you're filtering by also has to be a date. So it ends up being kind of a long function, because you're saying, I want any dates greater than or equal to, and then you can't just type the character string. You have to put that character string itself in an as.date or an as.posix. So it can get a little long. Gabby, I wanted to check in with you as well. Are we covering what you were hoping to learn?
Yeah, absolutely. Absolutely. It's all new, and I think I will have questions when we keep going with the lesson then.
Okay.
Yeah,
great.
Thank you.
Awesome. So the next thing, if you want to follow along this next part, there is in the repository, go back, a very, very small that's like 6 lines or something, data.csv. It's just a test case. I wanted to show reading in data, and I have it, I have it locally. So it might take you a second to get that data set. Reading in data. My notes have reading in data 2 different ways. And so depends on whether you like to use read.csv from base R or read_CSV and its equivalents from the readr package in the tidyverse. I think there's pros and cons. Personally, I think there's pros and cons to both. I'm very familiar with read.csv at being, having been around longer. And the code to read in dates and times could be slightly longer because for each character string column, character type column that you're reading in, that's dates or date times, you have to use as.posixct or as.date on it to convert it to date the correct format inside R. Read_CSV from the readr package is smart. It tries to guess what you want. And so if you have dates and times already in the unambiguous format, that ISO 8601 standard, it will read those in. But it is also hard, like if it's not in that format, you have to do a little bit more specifying to specify the format. I always have to look that up. And you also have to be very careful. It assumes the dates are the UTC, and it assumes the date times are your system time zone. So to avoid, again, you really want to be careful to avoid those things. So first, we're going to do just regular read.csv base R way, and that's going to let us review for a second as well what we did earlier. So I'm set my working directory to be the folder where my data.csv are. You feel free to do the same. I'm going to call it dat read.csv data.csv. So that's my base R. I haven't loaded any packages. So far, I've used 0 packages, right? There's no library arguments anywhere. I'm going to read that in. Oh, not even 6 lines, it's 5 lines. I'm going to click over here and just look at it. So this is just a very, very tiny example, corner of what might be your very large spreadsheet that you get off an instrument, for example, some kind of automated data collection. I've got a date column, got a time column, I got a DT, a timestamp. And if I looked and I did my str on my DAT, my data frame, all 3 of those columns read in as character strings, which is fine, right? Because again, like I'm perfectly comfortable. Oh, I am going to use dplyr for this next part. So just to make it look a little neater, but date, if I do a clean version of my data frame, I'll call it dat_clean, and I'll assign it this dat. And I'll use this piping from dplyr to create some new columns. So I especially want my date and my DT columns. I guess I currently, I want my date and my DT columns to be different. So date clean. What would I use here? What should I type here to get this 27-APR-22 into a date format in R? Feel free to unmute yourself and shout out the answer. Well, first, which function should I use here?
Would that be as date?
Yeah, very good. As.date. And my first argument is this column name, right? So I've got this date column name, and because we're in dplyr, I don't need to put it in quotes or anything. I can just type date as my first argument. If I just did that, I'm getting that not in a standard unambiguous format. So what does that tell me I need? Dan, what should I add here?
I'm not sure.
So I have a character string here that's 27-APR-22. It's not in the standard unambiguous format. So what should I
Oh,
add to
for-
my as.date?
The format.
Yeah.
Yeah, okay.
So it's format argument, format equals. Do you want to take a stab at what should go in my my double quotes here?
The what is it?
The day, right?
The B? No.
Yeah, a B is in here somewhere, a lowercase b. It's the second thing though. What's the first thing? What's the 27?
The day, but
Yeah, so I think that's percent lowercase d.
okay.
And I
And-
need to account for this dash.
Oh, the dash between each of them,
Yeah,
and then the year.
another dash. And here I don't have a 4-digit year. I have a 2-digit year. So I think it's a lowercase y. Pretty sure. Let's try that. Let's see if it works. Hey, it worked. We in our dat clean, we have this column and it looks pretty nice. Okay, and then I want DT here, character string. And I have a character string input. So which function